Good morning, students. Today we are going to start our next physics e-class. So, in the previous lecture, we talked about the average velocity, average speed, and the acceleration of the object. So, whenever we are just talking about the acceleration of the object, then acceleration is defined as the rate of change of velocity. That means whenever there is a change in the velocity of the object with respect to the time, then that amount of change in velocity with respect to the time is treated as the acceleration of the object. Now, whenever we are talking about the acceleration of the object, we are two special cases for the acceleration of the object. Very first condition, in the starting, very first we are having the normal acceleration, in which we are having initial velocity is lesser than the final velocity. That means the amount of final velocity is greater than the initial velocity. That is the normal acceleration. That means velocity of the objects will keep on change with respect to the time. In the next case we are having, that means that is the next case that is related to the retardation of the object. That means that will be the negative acceleration of the object. So whenever we are talking about the retardation or the decrease negative acceleration of the object, that is the situation whenever we are having initial velocity is greater than the final velocity. In the very first condition, final velocity is greater than the initial velocity, but in the second condition, whenever we are talking about the negative acceleration, that is initial velocity is greater than the final velocity. That is the amount of the retardation or the negative acceleration. We can say that that will be the negative acceleration. So we are having many more numericals that is also related to the retardation. The difference in the normal numericals, normal conditions, and the retardation conditions of the retardation, that means whenever we are getting some amount of the acceleration, that will be the value of that acceleration will be treated as the positive. But whenever we are talking about the negative acceleration, so whenever you are calculated as a negative acceleration, the amount of the acceleration you get in the numerical value, that will be as a negative amount. After that, today we are going to start our next topic, that is the graphical representation of the motion. So very first we will talk about what is the graphical representation. Graphical representation, whenever we are plotting the graph of any of the values or any of the variables, so graph always depends on the two variables or the two values. So using a graph for a pictorial representation of the two sets of the data is called the graphical representation of the data, in which, that means whenever we are plotting a graph of any of the condition, any of the situation, in that particular condition, the value of the one variable will depend on the value of the second variable. So with the help of this graphical representation, we can directly show the variation between those two particular quantities any without any theoretical expression. That means whenever we are having the graph between the two quantities, suppose we are having the graph between the speed and the distance, whatever is the shape of the graph, so we can directly state the condition, or we can directly express the condition of the whatever condition we are having in that particular graph or of the object. After that, whenever we are talking about the graphical representation of the motion, so we are having the number of the graphs in the between the different physical quantities. That means we are having the graph between distance and the time, velocity and the time. Then we are having the graph between the displacement and the time. But in the class 9 we are having only the two types of the graph. Very first we are having the distance time graph, and the second we are having the velocity time graph. So as you all know about the distance time graph, the ratio of the distance and the time will gives us the value of the speed. So whenever we talk about the value of the speed, so distance time graph, it determines the change in the position of the object. So whenever we are calculating the distance time graph, or we are plotting the distance time graph, so it determines the change in the position of the object, the speed of the object, as well as we can determine the time with the help of the line graph. And so when in that particular scenario, very first we are having the uniform motion. So we already talked about the uniform motion. So equal distances traveled in the equal interval of the time, that is defined as the uniform motion. So whenever we are having the distance time graph for the uniform motion, that is always a straight line. So that is always a straight line. So if we plot distance time graph for the uniform motion, that is defined as the distance and the time. Distance is always represented along the y-axis and time is always represented along the x-axis. Right? So whenever we are plotting the graph for the uniform motion between distance and the time, that will always treated as the straight line. So whatever line we are getting after plotting the graph between distance and the time, that will be treated as, in the mathematical form, that is treated as the slope of the graph. Now the slope, whenever we are talking about the slope we will discuss later. So whenever for the uniform, you always remember one point, that is distance time graph for the uniform motion will always be a straight line. After that, whenever we are talking about the non-uniform motion, so non-uniform motion for the graph between the distance and the time for the non-uniform motion is always a curved line. Done. So we are already having the graph for the non-uniform motion, that is defined as distance is always plotted along the y-axis and time is always plotted along the x-axis. Done. So whenever we are calculating the distance time graph for the non-uniform motion, that will not be a straight line, that is always be a curved line, because as we know that object for the non-uniform motion, whenever object is having the non-uniform motion, then it will cover unequal distances in equal interval of time. So whenever the amount of the distance is not equal in every interval of the time, so we will not get the straight line graph. Right? So for the, always remember one point, so for the non-uniform motion we are having curved line as a distance time graph. So we are having, sometimes we are having the another situation for the distance time graph. So when object is stationary, so when object is stationary, so amount of the distance will not change with the time. Time will keep on changing, but the amount of the distance will not change. Done. So suppose we are standing at the distance of the 1 kilometer and we will keep on standing there for the 5 hours, so time will be keep on increasing, but we will not change our position, so distance will remain same. So all the time whenever we are having stationary object, so distance time graph is always a parallel line along the time axis or along the x-axis. Then so these three graphs we are having for the distance and the time. So after that we are having three more graphs for the velocity and the time. So as you know that velocity, the ratio of the velocity or the time will gives us the value of the acceleration. So for the velocity time graph we are having here the different situations. So very first we are having the condition and then the graph for the particular situation or the particular condition. So very first we will talk about moving with a constant velocity. So whenever any of the object is moving with a constant velocity, that means velocity will not change, but time will keep on changing. In that particular condition we are having parallel line along time axis. All the time we have to mention time, the quantity time along x-axis all the times, and the whatever the next change quantity along the y-axis. So in the next condition, that will be the graph for the object moving with the constant velocity. After that, the second type of condition or the second condition for the velocity and the time we are having moving with a constant acceleration. That means we are having the equal amount, the constant acceleration, that means the value of the, and that means any of the object will move with the constant velocity. So if we are having moving with a constant, if any of the object is moving with the constant acceleration, so in that particular situation we are having here the straight line. We are having here the straight line. So along the y-axis we will mention velocity, and along the x-axis we will mention the time value. And in that particular situation, initial velocity of the object will be equals to 0. So we are having here the two situation or the two sub cases. In very first case, whenever object having 0 initial velocity, or object will start from the rest, and after that object velocity of the object will keep on changing. In the second situation, any of the object having some value of the initial velocity, that means initially object will move from the 5 km per hour velocity, or the 10 km per hour the velocity, that means some of the value we are having for the initial velocity. So in the both situations, the state or the shape of the graph will change. In the very first condition, if initial velocity of the object is equal to the 0 and object is moving with a constant acceleration, so the value of or the shape of the graph will be treated as a straight line originated from the origin of the coordinate axis. In the next condition, we are having the sub case of the very first condition. If body have some initial velocity, that means body having some amount of the initial velocity, then u, so object or the graph of the for the particular situation will not start from the 0. It will have the some value along the y-axis, that is treated as the value of the velocity. That is treated as the value of the velocity. So we are having some amount of this value, this velocity here. So graph will not start from the rest, or it will start from the some point of the velocity axis, that is along the y axis. So the shape of the for this particular situation, or the velocity or the time graph will be treated like this. After that, we are having the next condition, or we will talk about what you define as a slope. How will we define the slope? Define slope is a mathematical terminology which is sometimes used in the physics. So whenever we are talking about the slope is a measure of the steepness of the line connecting two points. That measures the steepness of a line connecting two points. That is defined as the slope in mathematical language. After that, we are having the last condition for the velocity time graph. So in the last situation, we are having body having a constant retardation. Constant retardation. So whenever we are talking about the retardation, that means in that particular condition, initial velocity of the object will be greater than the final velocity. So body moving with a constant retardation and its initial velocity is not equals to 0. So whenever we are having this type of the condition, so we will have the shape of the graph will be like this. Done. So all the time along the x-axis we will define time, and along the y-axis we will define the velocity. Now, initially we talked about the retardation of the object. Retardation is the opposite condition of the acceleration, in which velocity of the object will keep on decreasing. Then when the velocity of a body will decrease, then acceleration is said to be negative, or it will be treated as a retardation. So what are the examples or the practical examples of the retardation in our day-to-day life? Suppose the landing of the aeroplane is the example of the retardation, because aeroplane is moving with the very high speed, and when aeroplane lands, then the speed of the aeroplane will keep on decreasing, and after some time the velocity of the object will be equals to 0, or when it comes to the rest. That means initial velocity of the object will be greater than the final velocity. That is the our practical condition or day-to-day life example. Second example, when we switched off the fan. So when we switched off the fan, so initially fan is moving with the some higher value of the velocity, but when we switched off the fan, then slowly the velocity or the speed of the fan will keep on decreasing, and after some times it will comes to the rest. So if we are writing this value in the mathematical term to understand the phenomena and for the numerical portion, so that will be treated as, for the retardation, initial velocity will be greater than the final velocity. For the retardation, always remember the point, initial velocity will be greater than the final velocity. So whenever any of the object is retarding, then you will get the numerical value of the acceleration is negative. Done. So whenever we are talking about the normal acceleration, then you will get the positive value of the acceleration. I hope the graphical representation of the motion will be clear to you all. Then this is the one portion of the graphical representation of the motion. In the next topic, we will define the equations of motion with the help of the graphical representation of the motion. So that is the most important part of our topic, today's topic. So we will discuss that particular topic in our next lecture, and that's all for today. Thank you.